Good afternoon, scholars. Okay, so we are here for our final presentation. Students have been working so hard all week, and they each have been working on a sphere, and they have been working on a budget. Just so you know, the budget is not real. We had to give them some parameters to go around to be able to come up with a mission. And they've been working hard. They are ready to show you what they have. Scholars, you have 18 minutes to talk about your mission, and then there will be 9 minutes of questions. Now, the panel, when it's your turn to ask questions, please tell us who you are, who you work for, or what you do. That way, the people who are listening will be able to tell who is talking at that particular time, especially the first time that you say it. It helps us a lot. All right, so we're going to start. We have some people coming in via the internet and then some already here. So we are going to start with our newest team, Cryosphere.
Good afternoon. My name is Tristan Corey. I am the project scientist for the Cryosphere. Today, Earth is in a climate crisis due to the problem of anthropogenic climate change. One of the impacts of climate change, and arguably one of the biggest threats that we face currently, is polar amplification, which is the phenomenon that occurs when heating in the poles accelerates and happens at a faster rate than everywhere else in the world. Our mission impact is based on the C8 objective in the Decadal Survey, and the Decadal Survey is a survey that is formed by the National Academy of Sciences, Engineering, and Medicine every 10 years. Now, our mission aims to investigate this question by advancing our understanding of polar amplification and exploring the causes and effects of polar amplification using new and innovative technology to get data for discovering the implications surrounding this phenomenon.
Hello, my name is Alex Abraham. I am the Deputy Project Scientist for the Cryosphere. Mission Impact will gather data on the causes of polar amplification and the relative significance of each. And this is important because polar amplification is tied to the global climate. And if the poles increase significantly in comparison to the rest of the world, the poles will be unable to regulate global temperatures, and that has drastic impacts on the entire world. Our mission proposal is that Mission Impact will gather data on albedo, Arctic oscillation, polar vortex, ocean currents, and water vapor concentration to inform scientists and politicians on how we can better make steps in the future to address polar amplification. Our partners in this mission are Northrop Grumman, USGS, and NOAA.
Hello, my name is Violet Miller. I'm one of the research scientists for the Cryosphere. Impact is, in its study of polar amplification, is specifically targeting 3 key areas: sea ice and how the reduction in sea ice area affects albedo and radiance, the polar vortex and how a change in the erraticness of the polar vortex affects global convection currents, and ocean currents and how a change in strength and temperature affects weather patterns in other parts of the globe. In order to measure the characteristics of albedo and sea ice area, we are using the MODIS instrument for the polar vortex in order to extrapolate such things as current strength and where the jet stream is containing the polar vortex. We are measuring surface temperature of both the ocean and land, and wind speed, and atmospheric temperature and pressure. For ocean currents, we are measuring the surface temperature of the ocean as well as the wind speed directly above the surface of the ocean, which allows us to predict the strength and temperature of currents.
Good afternoon. I'm Adar Sivaganation, and I'm the research scientist of the cryosphere team. Our mission utilizes three instruments, MODIS, ATMS, and Poseidon 3B. MODIS helps us record water vapor concentration and surface temperature. ATMS helps us measure the surface area of ice and snow while providing data on air pressure and the vertical distribution of temperature. And Poseidon 3B helps us record wave height, wind speed, and current velocity. In terms of data, we'll be processing the data using 3 CPUs, and that data will be temporarily stored on the onboard storage systems on the satellite, and that will be transferred to the DAAC, the Distribute Active Archive Center by USGS, where the data will be stored. The data will be transmitted with X and S bands. X bands can transmit the bulk of the data, but can't penetrate clouds. So we're going to mitigate this issue by implementing S bands as well, which can. And in the case that our instruments do fail or malfunction, we have ground truthing instruments that can cover our targeted region.
Good afternoon. My name is Ola Amar. I am a budget analyst. Our mission partners are NOAA and USGS. Through this partnership, it will allow us to operate in Greenland as well as provide ground truthing so that we can utilize their buoys to collect information on the climate as well as the speed and temperature of the ocean currents. We will also be getting 30% off of all our instrument costs, which also helps with the budget. We are also partnering with Northrop Grumman, who are also in charge of the maritime navigation, oh my gosh. And specifically the Navy ships. Through this partnership, it'll help us collect data on ocean currents that exert force on the underwater areas of the boat. And through this data, we will be able to understand the changing currents that polar amplification can cause. They will also be providing the Antares rocket as well as the Geostar 3 satellite bus. We will also be receiving 20% reduction off cleaning costs, which also does help with the budget as well. They will also be benefiting from this mission because they can use our data to execute their environmental organization goals. It will also help with navigation for the Marines and also the U.S. Navy, and also monitoring ocean currents.
Good afternoon. My name is Nicole Dang, and I'm the other budget analyst. Our proposed cost is excluding our partners and joint mission negotiations, and is $1,357.2 million. However, because this cost exceeds our individual mission budget of $260 million, with $13 million for our 5% budget reserve, Impact has established partnerships with NOAA, USGS, Northrop Grumman, and cost-sharing negotiations with the other spheres in order to reduce our costs. After collaborating with the other spheres on our combined mission, our baseline cost, which is how much we are currently paying, is $186.4 million. Our costs over time include our instruments, mission operations, data collection, thermal systems, power systems, propulsion, and electronics. Moreover, an additional $10 million to our budget is allocated for mission outreach. After finalizing our collaboration with all of the 4 other spheres, our overall mission cost is $1.1 billion, which is within the joint 5-sphere budget of $1.2 billion. The cryosphere pays for 16.2% of the total cost, and our total savings for the cryosphere are $983.3 million.
Good afternoon. My name is Darren Wing, and I'm the Launch and Orbit Analyst. For our mission, we will utilize the Antares launch vehicle, and we'll be launching from the Wallops Space Flight Facility. This rocket will be able to carry a 6,120 kilogram payload up to low Earth orbit. Once in low Earth orbit, we'll be able to maneuver our satellite to a sun-synchronous orbit at an inclination of 80 degrees and an altitude of 622 kilometers. This is a near-polar orbit, which will allow us to see the entire planet, and especially Greenland, which is our main area of study. We plan our launch to be on September 2032 and have a seven-month calibration period and a 6-month data collection period. After the 6 months, we will do a status check of all of our instruments, and if all systems are well, we will continue for another 3 months with a nominal end and deorbit at 10 years. The satellite bus we will utilize is called the GeoStar 3 by Northrop Grumman. This structure is able to carry our instruments with a 1,000-kilogram payload, and all of this assembled will be able to fit on our rocket and still launch. The propulsion system we will use is electric and chemical, which allows us to do orbital maneuvers throughout space.
Good afternoon, everyone. My name is Astrid Kosmajeski, and I'm the Contamination and Risk Analyst for the Cryosphere team. Behind me, we have the bus satellite layout. We have our 3 instruments we are using at the top, highlighted in yellow, Poseidon 3B, which is active, and MODIS and ATMS, which are passive. MODIS and ATMS are on the right, whereas Poseidon 3B is on the left because the 2 active and passives can't be together. We also have CMPs located near each instrument. This is to monitor contamination levels. Particulate and molecular contamination on board the spacecraft are inevitable, and these are things we need to mitigate, but they can be prevented. So we chose the ISO 5 cleanroom level. This is best for Earth observing instrumentation. And we also chose different part qualities based on our strategies. We also have, like I mentioned, 3 CMPs on board to monitor contamination levels, which will help get the best data we can. As for risks, our main risks that we mitigated the best were atomic oxygen, space debris, and outgassing. Atomic oxygen was mitigated by silicon dioxide coating. Space debris was mitigated by chemical maneuvers. If there's something in the way, we use chemical thrusters to maneuver. And outgassing was mitigated by pre-cleaning and bake-out.
Good afternoon. My name is Caden Booth, and I'm the Calibration Validation Scientist. And with our partnership, as spoken before, with NOAA, we are going to utilize shipments to be able to deploy 12 sectional data buoys, specifically on the current that is found above northern Greenland. We are going to utilize them to scan for 3 primary functions. It is going to be sea level pressure, water and air temperature, and wind speed with direction. The viability of this operation will help not only just our partnering factors as well as but it will also, whatever systematic things they want to utilize them for, they are allowed to once our operation of about 10 years has been concluded. Now, on the topic of time frame, we have a bit of a concern because the data buoys themselves have a 3-year period where they must have required maintenance toward the operational power sources of solar panels must be adjusted. But fear not, because the budget has been implemented to where we have reserved cash within our budget that will be utilized primarily for repairs and specific units. And the system itself, although it is solar powered, it has that stored power through a 24-hour activation period. It will be consistently running fluently, and it will not deactivate during nighttime or any other hour.
Hello, my name is Olivia DiNapoli, and I am the applied scientist for the cryosphere. Our data tells us the relative causes of polar amplification. Without this data, we wouldn't be able to accurately pinpoint each cause for polar amplification. Our data will also tell us which causes of polar amplification have bigger impacts around the world. Some societal impacts. So Greenland, their coastline is receding because of ice melting. This is causing Greenland's mass to decrease, and this also creates more land to be available for agriculture. So some positives are Greenland will be able to have more crops and longer growing seasons, but this does have a negative effect on the rest of the world, as this leads to a disruption in the ocean currents and how plants are to grow. Additionally, boat routes, polar amplification is one of the causes for weakening currents and ultimately affects marine navigation. On to economic impacts. Greenland, with this new kind of agriculture, has led to a new source of income and is beneficial for them to use. With that, more industrial companies and processes are using the land in an unsustainable way for their own profit, so this continues to add to the issue of climate change and emission of greenhouse gases.
Good afternoon. My name is AJ Giza, and I am a mission outreach analyst. The name of our mission is IMPACT, which stands for Ice Measurements for Polar Amplification and Cryospheric Tracking. The mission logo has NASA's 3 primary colors, red, white, and blue. It depicts an iceberg with a satellite orbiting above to show the focus of the IMPACT mission and researching the Arctic. Additionally, NASA's logo and the partner logos are included on the patch. 15 snowflakes line the borders and represent the 15 primary mission team members of Mission IMPACT.
Good afternoon. My name is Aaliyah Logan, and I'm a mission outreach analyst for the Cryosphere team. And for educational outreach, we want to make sure that all educational institutions can have all the data they need and the ways that they can use them. To do so, we want to make sure that we partner with universities so our scientists and engineers can have Q&A sessions and speak about our mission and its goals. We want to make sure we have lesson plans that are downloadable for teachers so they can teach their students. And for internships, we want to make sure that students can come in and use hands-on learning to figure out what our mission is about. And then lastly, we have online platforms. Because social media is such a big use of how to gain information, we have 3 social media platforms that IMPACT will be advertised on. It will be Instagram, YouTube, and an online website. YouTube will be used to broadcast live events that people cannot attend. Instagram will have instruments from MODIS. We'll have pictures from MODIS that we can show off what our satellite is seeing, and team pictures to give a personal feel. And our online website will show easy accessible data, our application tools in the application tab, and tabs that can show off our upcoming events. People have something to look forward to. Thank you.
Yeah, thanks a lot. That was a great presentation. I'm Joe Hanley. I'm a program manager for the Air Force next door at the Air Force Base, and I do work in geospatial systems. I guess my one question on the outreach, you talked about outreach. I was wondering if you considered international kind of outreach, especially since the focus is on Greenland, maybe Denmark, or where they could contribute to the project.
So for our international outreach, I feel like I wanted to more so go to international fish markets, because the main problem with oceans is that ocean circulation is changing because of polar amplification and how that water is like changing into like fresh water and decreasing salinity. So we want to make sure that fish companies know exactly what's going on, so when their stock goes decline, they have a reason to tell their people what's going on.
Okay, thank you.
Hi, my name is Ivanka Todd. I'm a project manager here at NASA. I work in operations. On the ground truthing aspects of it, where you have floating solar-powered systems that kind of validate some of the measurements, how will you ensure, or what provisions are in the project to replace anything that basically stops working? How will you track, or is there anything in the project to track that, or is there something in the budget to account for the loss of equipment that's floating in the ocean?
Well, I feel like I can answer that question. Well, if the system is to malfunction with any of the data buoys outside, we have 12 units that will be spread across an ocean current that is flowing from the Arctic Ocean into the Atlantic. The reason we have 12 of them is because of that exact fact of a potential malfunction of any of the systems, and there is about I believe it is about a 1 to 1.5 month connection that will ensure that we know that there's an issue that's going to occur, and we can send out naval teams to go out there and scientists to be able to repair those issues that are going to occur. Will hopefully not occur, but if they are to occur, we will be able to assess a mission to be able to go out there and be able to solve that issue, whether it be from the data itself, the power storage, or any of the functionable units that are on the below that does the research itself.
And if I ask one more question on the data analysis, I'm sorry, were you going to add to the?
Oh yeah, I just wanted to add, as for the budget, we have a budget reserve, which is 5% of our total budget. And then we're gonna, if any of the buoys happen to malfunction, then we would be able to use that budget reserve towards fixing those.
Excellent, thank you. That's an outstanding solution here. And a follow-up question on the data analysis. I know there's not a lot of time to talk about it in a presentation like this, but can you elaborate a little bit more about the resources that you will be putting toward data analysis, the tools, and who will actually be doing it? I understand you'll be sharing the information with universities, but can you elaborate a little bit about what you had in mind on the data analysis capability? Like platforms and what do you envision that to happen?
Are you asking in terms of where data will be published for
people
to use?
Exactly.
So for outreach, we were planning on publishing the data not only on our website, but also digital libraries for researchers and students at universities to use for their own research.
My name is Erica Smith-Edwards. I am a master teacher, and I wanted the launch analyst to tell me why they chose that time of day and time of year to launch.
Yes, thank you for your question. We chose around September because our mission didn't have a specific need of a specific date, but Biosphere, the other sphere we're collaborating with, has a specific timeline they want to, and in order to accommodate for, I think it was a spring data collection for their mission, we had to do it within 7 months before spring. So that was our reason, because we have to account for calibration as well. Thank you.
Bill Moore, Hampton University. So the polar regions present a couple of challenges to imaging missions, one of which is that they tend to be pretty cloudy. The second of which is that the aurora can be kind of bright and actually get in the way of what you want to look at. So what approaches do you have to avoid those problems?
In terms of piercing the cloud cover in order to continue mapping sea ice, our ATMS tool is able to do that. It's a microwave sounder. And additionally, if our data from ATMS is not enough on the satellite, we are not currently using it. But there is another tool, synthetic aperture radar, that would also be able to pierce the cloud map in case, for some reason, our atmospheric sounder malfunctioned. We did not get to considering the aurora borealis in terms of obfuscating our measurements, but we'll have to look into that.
Thank you.
Will be our last question. You mentioned K through 12 resources. As a kindergarten teacher, how would I implement this in my classroom to engage my students?
So for kindergartners, we had an interactive game that we're going to post in our applications tab in our online website. Basically, it was going to be more of a lesson plan, but in the way of like a click through. So you'll be able to read it and go through it. There'd be big pictures and characters and colors. So it could appeal to them and keep them engaged, but also give them the information in simple terms that they need.
Hi, I'm Alex Zahn. I'm a thermal engineer here. Quick question. I heard, correct me if I'm wrong too, this is a 10-year mission life. Just to curiosity here, was there any thought given to redundancy in any of your systems? As far as if you lose one of the instruments, do you lose what you're trying to shoot for from a science perspective?
So among the three instruments that we are currently using, MODIS, ATMS, and Poseidon 3B, there is a significant amount of overlap. Instruments that we have selected for specific data measurements are the most optimal for those measurements. But in terms of sea ice mapping, like I said before, both MODIS and ATMS are able to do that. So if one of those instruments malfunction or is in some way damaged, we can continue to gather those valuable measurements. There are also overlap for water vapor measurements, wind speed, and many of our other measurements.
Today, thank you, Cryosphere. Great job. Our next team is Hydrosphere.
My name is Adair Poyer, and I'm project scientist for Hydrosphere, and this is our mission COAST, which stands for Coastal Current Observation and Analysis of Sea Trends. This mission falls under NASA's strategic plan, specifically under the section of Discover, point 1.1, which is to explore the climate and Earth. It also falls under the Decadal Survey of 2018, and that this mission will study rising sea levels, accelerating coastal currents, and increasing chance of flooding and storm surge. This mission will also study how the impacts of global warming cause sea ice to melt and warm the ocean, which causes sea levels to rise, and also the following impacts of this sea level rise, including changes in salinity, density, and temperature, and other ocean factors that change ocean dynamics, such as currents. This main study will be on accelerating currents, which has been suggested by many climate models but has not been proven with solid data from satellites, so this is the primary objective of this mission. The areas we will primarily be focusing on are coastal current regions and also shorelines, and this mission overall will study changing dynamics within the hydrosphere and also accelerating currents and increased chances of flooding and storm surge.
My name is Quinn Cook, and I'm the Deputy Project Scientist of Hydrosphere. COAST will identify the frequency and severity of storm surges and flooding, offshore currents, and decadal variability to help us understand the ever-changing ocean. On top of this, COAST will improve the understanding of sea level and its sea level rise and its impact on the variation of certain factors, such as current speed, current temperatures, wind speed, and wave height, all in the prospect of reducing uncertainties in storm surge and flood predictions for coastal communities. And while coastal communities will experience the forefront of these effects, the mission has massive implications for the entire world. Storm surges and flooding are predicted to inhibit coastal industries while simultaneously draining the global economy as countries attempt to repair the damage done to their coastal infrastructure. Plus, with the JSON 3 decommissioning in 2025, now is the time to implement COAST. COAST will operate in the absence of the JSON 3 and will continue understanding and monitoring the changes in oceans through consistent and accurate data analysis over a long period of time.
My name is Samantha Ho, and I am the research scientist for the Hydrosphere. This is a traceability matrix which gives a simplified overview of the instruments and the objectives that we've used in our mission. Our mission goal is to identify the frequency and severity of storm surges as well as floods, offshore ocean currents, and decadal variability in the oceans to better understand how the hydrosphere is changing. In order to carry out this goal, we have determined 2 science objectives. Our first objective is to determine the strength of storm surges and floods by measuring the rate of wind speed, wave height, and current speed using our instrument, the Poseidon 3B. Our second objective is to observe the variables that determine the rate of change in global sea level rise, as well as changes in ocean heat and their effects on the speed of offshore currents. We will use our instrument Poseidon 3B to measure the rate of change in ocean height, as well as the speed of offshore currents. In addition, we will measure the rate of change in ocean temperature using MODIS.
Hi, my name is Advitya Srinivasan, and I'm a research scientist. As Samantha stated previously, the main mission measurements are those of the rate of change in wave height, current velocity, and ocean height. As such, we had to find the perfect instruments that would collect these above parameters. After doing research on missions that required current speed and height readings, I found out about the Jason 3 mission, which utilized the Poseidon 3B altimeter. The Poseidon 3B altimeter measures ocean topography, models global ocean circulation, and tracks variation in the ocean circulation, which can lead to overall changes in weather and heat patterns. This matches up with our mission goals perfectly. The instrument also only weighs 70 kilograms and uses 78 watts per hour. The Poseidon 3B measures the round-trip travel time of the microwave radar pulses bounced off of sea surfaces, from which precise distance is determined for about 3 to 4 centimeters. The second instrument we are using is called the MODIS. The MODIS measures vertical distribution of temperature and water vapor and only weighs about 230 kilograms and uses 162.5 watts of power per single orbit average. The MODIS is a satellite optical-based sensor that is used in the Earth Observing System EOS missions Terra and Aqua.
My name is Drivya Lassetti, and I'm the budget analyst for Hydrosphere. Our critical mission partners are the NOAA, USGS, and Lockheed Martin. The NOAA and USGS were chosen as our first critical mission partners for their extensive data collection into ocean currents. In addition, partnering with them could yield special access to their global ocean currents database that has readings dating back until 1962. Now, coupling these past readings with new readings from our proposed satellite could yield inferences over a much longer period of time than we actually need to operate for. In addition, partnering with the NOAA and USGS gave us a 30% reduction to our instrumentation costs. Lockheed Martin was chosen as our final mission partner as we needed their Lockheed Martin solar panels for our power budgeting, and partnering with them gave us a 10% cut to our space qualification costs. Moving on to our budgeting. Our baseline budget for just our mission without any shared instrumentation and facilities, our proposed budget, was $992.5 million. Our baseline budget, once we actually started sharing these instrumentation and facilities with other missions on board the satellite, became $184.9 million. Now, beyond these budgets, there are additional costs over time that need to be considered. These include the DAACs, which are the Distributed Active Archive Centers, satellite antennas, and things like the S and XL band communicators. Lastly, let's look at the cost breakdown. In our cost breakdown, mission operations and instrumentation came in as the largest contributors to our budgeting problems. Mission operations came in at 28%, while instrumentation came in at approximately 33%. As far as savings go, we had the second highest savings out of all the missions on board the satellite at approximately $800 million.
Hello, my name is Kenny Calhoun, and I'm the launch and orbit analyst for the Hydrosphere team. For our mission, the launch site we'll be choosing is Wallops Flight Center, and the rocket we'll be using is Antares, and the satellite we'll be using is Geostar 3. The Geostar 3 will be orbiting around the Earth in a sun-synchronous orbit. For our mission timeline, the launch date will be September 2032. And after that time, we'll have 7 months of instrument calibration before the satellite will be activated on April 2033. The mission will last for 10 years and it will end on April 2043. And after the mission time, if the satellite is no longer in need, the satellite can be decommissioned and deburned in the atmosphere of the Earth.
Hi, my name is Charlotte Draney, and I am a contamination and risk analyst for the hydrosphere. Above me, you can see the satellite bus layout, and it is important to notice that the MODIS is separate from the Poseidon 3B altimeter. This is because the MODIS is a passive instrument, which is why it is next to ATMS, which is also a passive instrument. And our Poseidon 3B altimeter is an active instrument. Another thing that is important to the layout of our satellite is the cleanliness and contamination levels of each of the components. So all of our instruments have to be precision cleaned in order to be space grade, and this ensures that they collect accurate data. Therefore, anything that is close or bordering these instruments has to also be precision cleaned to space grade. So that would be things like our radiator, heat pipes, those all have to be precision cleaned. And then things that are further away, such as the electric and chemical thrusters, the onboard data storage, and the CPUs do not have to be precision cleaned. Here's our risk matrix. Like any mission, there are certain risks that would possibly jeopardize the success of our mission. Two major risks one would be contamination due to outgassing. Our mitigation for this is using the ISO 5 clean room, which is the highest clean room that you can have for scientific data gathering satellites. And we would be cleaning all of our instruments and components in this clean room to mitigate that outgassing risk. And then another inherent risk is orbital debris, which we will be using data available made by the SSN, or the United States Surveillance Network, to be able to track orbital debris and use our electric and chemical thrusters to maneuver around them.
My name is Brooklyn Maciejewski, and I'm a contamination and risk analyst for the hydrosphere. Space is an extreme environment that can both damage our satellite and jeopardize our instrument measurements. To mitigate satellite damages, we will implement protective coatings such as silicon dioxide, as well as utilizing CMPs to monitor contamination levels. Furthermore, to ensure sustained instrument accuracy, we will utilize thermal regulators, as well as implementing instrument modifications to accommodate for our instrument limits.
My name is Shreya Sridhar, and I'm the calibration validation scientist for the hydrosphere. As far as validation and ground truthing, we'll be using the NOAA and USGS partnerships, which provide data on North American coastline current data using their tide and current database. If there's statistical correlation between these coastline data and the data that is collected by our satellite, then we can then extend that data to global coastlines around the world. In addition to this, we'll be using our ground station DAAC in Greenbelt, Maryland, which will help to analyze and validate the data that is received from our satellite. For acclimation periods, the MODIS has an acclimation period of 51 days, and the Poseidon 3B has an acclimation period of 33 days. These are selected based on the past missions such as the JSON and the ISAT, which use these same acclimation periods. For calibration, the Poseidon will use an onboard GPS for positioning, as well as antenna radar calibration, as well as radar cross-sections. The received radar signals will be compared to these cross-sections, which provides us data on target reflection and therefore greater accuracy in our calibration. The second satellite that will be using calibration is the MODIS. For this, we'll be using the solar diffuser. The diffuser reflects sunlight and compares it to known sunlight reflections, and that helps to calibrate the changes in any temperature in the sea surface. We'll also be using SRCA, which helps to measure the intensity of radar wavelength, and that includes spatial and spectral calibration, which looks at the accuracy of the images that are produced by the satellite. We'll also be using blackbody calibration, which again is another mechanism to see if there are any changes in temperature. And then lastly, we'll be using sun and moon sensors to again calibrate positioning and orientation of both of our satellites.
Good afternoon. My name is Sade Burboy. I am an applied scientist. The importance of our mission coast has many different aspects. Maintaining or monitoring ocean currents will give us a better understanding of sea level change and what can be done to improve upon it in the future. By identifying the frequency and severity of storm surges, it will increase public awareness. For example, shown on the right is the U.S. Geological Survey tool, called the Sea Level Rise Data Viewer, where the public may use it in order to monitor which section, which part of the world they live in that affects them with sea level change and flooding. And it can be used for preparation to lessen the severity of damages in their area. Circling to impacts, a plethora of economic impacts locally and globally. In terms of local impacts include income loss and infrastructural repair due to flooding, as well as tourism declining due to a loss of beaches. For example, 6 feet of shoreline have been lost per year since 2018, according to the U.S. Geological Survey. Also, in terms of the global effects, a large portion of the global economy will be dedicated to infrastructural damages annually by the year 2100, according to the U.S. Geological Survey. One of the aspects of our mission is to enhance preparedness about emissions, as well as contribute to, and our data can be used to contribute to updates on infrastructural repair and building, to reduce recovery costs.
My name is Cassandra Kaminsky, and I'm an applied scientist for the hydrosphere. When talking about sea level rise, it's important to note of the societal impacts. So first is storm surges. So due to sea level rise, storm surges have become more frequent as well as increased in size and intensity. So the impacts of storm surges would be destruction of property and loss of lives. Moving on to flooding. Due to sea level rise, flooding has also increased, especially near the coasts. Places like low-lying wetlands and low-lying cities are especially vulnerable when it comes to flooding. To give an example, Florida is 26% more likely to feel negative effects to flooding over the next 30 years. The impacts of flooding would be destruction of property, loss of lives, and damage to resources such as vegetation. When talking about flooding, there's another important thing to note, and that is disease. So to give an example, if you were to eat something that was contaminated by floodwater, you could get a disease such as E. coli. And finally, water supply. When sea levels are rising, the salt water is intruding into the fresh water, therefore polluting it, therefore causing water scarcity.
My name is Sinead Maloney, and I'm the Mission Outreach Analyst for the Hydrosphere. So you can see our mission patch above me, and it is depicted with a globe with water levels rising on it. We chose to do this because it shows how our mission plans on analyzing how the rise in sea level affects the globe. We also have our satellite and mission partners on the side of our logo. Lastly, we have both the abbreviation of our mission name as well as the full spelled out mission name on our patch. Our education plan includes coloring books and presentators coming to school, which can be accessible for many teachers so that they can spread the news about our mission. And as for our public presence, we will both be on and offline. Online, we will have our website, and we will also be sending mass emails which include information about our mission, and we will be having TV segments which will inform the public about our mission. Offline, we will have radio interviews, and we will also be published in the Spaceport magazine, which is NASA's official magazine, and we will be published in many university newsletters. We will also have a social media presence. We will be on Instagram, YouTube, and our website. On Instagram and YouTube, we will be publishing videos about behind the scenes and about more information about the instruments on our mission. Our biggest outreach event is the launch week, which we are collaborating with the other spheres so this will happen. For our day, we will include giveaways and merchandise. Some of our merchandise will include t-shirts, speakers, and water bottles, which are shown on the slide. We chose these items because they are reusable, so as the mission keeps on going, people will be reminded of them while they continue to use the merchandise that they bought. Thank you.
We now open the floor to any questions.
to someone to appease the concerns of individuals. Thank you. How would you justify your mission to appease the concerns of taxpayers who do not live along the coast and might not be concerned about flooding?
Thank you for your question. For people who do not live in the coast, let's say people who live more center, like say the Great Plains in the United States, flooding also influences them as much as it does for coastal communities, because when the sea levels rise, when the sea levels rise, the water reaches into the groundwater, which can affect the aquifers as well and can influence water once it reaches into the Great Plains, which would affect their drinking water. And if they were to be a farmer per se, that would affect their crops.
Hi, my name is Jess Savage. I am a previous VESS scholar, and I currently work at NASA as a hypersonic design and systems application intern. And I was just curious about your launch vehicle. So what is the reliability of the launch vehicle you chose, and why did you choose it?
So we chose the launch vehicle because it has a capacity to launch up to 6,000 kilograms of payload mass to low Earth orbit. And the type of orbit we chose, sun synchronous, is lower. So we chose a safer vehicle that can launch a satellite, which will weigh around 1,000 kilograms.
Bill Moore, Hampton University. I was pleased to see you call out the importance of continuity of observations, particularly with reference to the JSON-3. But it seems like your timeline is going to leave about an 8-year gap between the end of JSON and the start of your mission. I'll maybe just try to speak louder. Is there anything your mission is planning on doing to cover that gap in observations?
Absolutely. So we do have ground truthing methods in place in tidewater stations as well, and we are planning to use those during the gap between the JSON-3 and our mission. The JSON-3 is an excellent mission, but ours continues that as well as adds some more elements to it, such as focusing specifically on current variations and variations in floods, especially in coastal areas. And I agree that there is a gap between the JSON-3 mission and our mission, and we are planning to do more research on that, but for now it's just going to be ground truthing.
I have a question from Ms. Tara Wise. She asked, if you wanted your mission to be recognized or remembered for one thing, what would that be?
I think that one of the biggest and most important factors of this mission is definitely the new information that it would provide on future weather and hazard reports, and it's going to be very impactful in kind of predicting what future oceanic dynamics are going to look like based on trends of conditions before, after, and during flooding and storm surge. So I think it would definitely help to clarify some of the gaps that are currently in modern prediction methods.
I have Mary Hing. I'm a master teacher for VESS. I have a question for a budget. If you were given unlimited money, what would you do with it for this mission?
Right, so there were a few measures for accuracy that we definitely would have liked to spend our money on. For example, the DORIS, it would have been great for calibrating our instrument further instead of relying on one of the instruments that one of the other spheres is using, the SARS. And along those lines, the SARS, one of our other spheres could have used a far more advanced version of it. If we had an unlimited budget, we would likely invest in an INSAR. Along those same lines too, one of our satellite buses, if we had unlimited money, we would definitely go for more cleanliness on all of our aspects because it can't be too safe. And when it comes to our actual satellite structure, we could probably add more safety mechanisms in and contingencies.
Yeah, hi, Joe Hanley, Program Manager. I was just wondering, what is the rationale to do all this collection from a satellite versus the buoys that you have? Is it more cost effective to do that from buoys versus launching a satellite? What do you get that's different?
So right now, our partnerships only have data that is in North America. So we don't have data currently in global coastlines. So because the ground stations are only able to do so much and in a very local area, using a satellite actually helps us to get more global coverage that we haven't gotten yet.
Okay, thanks.
So for the mission scientists, have you considered, I'm sorry, this is Ivanka Todd with NASA. You talked about changing shorelines, actually, and I'm curious, how will the mission account for changing shorelines? There's a natural change that occurs, and then there's, as you called, the climate change-induced change. How will your mission data collection process account for that?
I think we would definitely have to look into that more, but between it being a long-term mission, we would definitely see if there were constant trends or if there were more variation, like there would be in natural coastline recessions and that sort of thing, versus global changes on a long term.
I can actually add on to that. Like I was saying, our partnership with the NOAA and USGS gives us access to a much larger database that extends backwards to 1962. We have coordinating data for that timeline on some metrics of climate change and how we've actually been accelerating it, right? So we can look for a correlation between how the rate of climate change has been changing. And along with that, we can look at how these coastlines have been changing. So we can say where are the exact zones where it's actually climate change making the most of this effect, and we can look at our data and say, okay, this is where our data is more significant.
We have time for one more question. All right. Thank you, Hydrosphere. That concludes all of our questions. Our next team will be Atmosphere.
My name is Jude Malik, and I'm the project scientist for the Atmosphere Group. Our mission is the atmospheric raise and reduction of weather severity, or ARROS. Since our focus is on the atmosphere, we decided to make our mission about the weather. NASA's strategic plan addresses the discovery, exploration, innovation, and advancement of science. Our mission is focused on the discovery aspect, establishing connections between convection and storm intensity. The Decadal Survey is a data bank of questions addressed by scientists who are experts in their field, and it is meant to address mission goals for the future. We're using the W4 priority application question from the 2018 Decadal Survey, which states, why do convective storms, heavy precipitation, and clouds occur exactly when and where they do? We're hoping to establish connections and between convection currents and weather severity, frequency, and movement patterns. This is because of climate change affecting the convection currents and what we think will be affecting the weather patterns. The atmosphere is also affected by this data as the convection currents are creating instability in the atmosphere.
I'm Michelle Eno, and I am a deputy project scientist. The goal of our mission is to investigate the relationship between convection currents and the severity of weather in the world, with a focus on understanding the movement, duration, frequency, wind dynamics, and temperature changes associated with storms. And so this goal was driven by the fact that storms and convection currents are becoming more unpredictable due to changing atmospheric temperatures that are caused by climate change. By studying the influence of large-scale convection patterns on storm frequency, analyzing the impact of convection patterns on wind direction and speed within storms, and monitoring temperatures during the entire mission, ARROS aims to use this data to understand the movement and length of storms. This mission will benefit all citizens, as a better understanding of how storms are changed can allow homeowners to better prepare supplies for storms, allow organizations to better prepare for habitat damage from storms, and assist policymakers in understanding where funding should be prioritized.
My name is Abby Chang, and I am a research scientist. The science goal of ARROS is to study the relationship between convection patterns and the severity of global weather in order to better understand the movement and duration of storms. To do so, we must look at three main objectives. The first one is to determine the convection pattern, or to determine how convection patterns affect the frequency of storms. The second one is to determine if there's a correlation between wind speed and direction and convection patterns. And the third is to monitor air temperature throughout the duration of our mission. The first objective requires that we measure location and frequency of storms. We will do this through the Moderate Resolution Imaging Spectroradiometer, also known as MODIS. MODIS can also help us by measuring the location of convection patterns for the second objective. For the second objective, we also require that we measure wind direction and wind speed, which will be done by the Advanced Technology Microwave Sounder, also known as ATMS. ATMS will also address the third objective by measuring air temperature.
My name is Kaylin Womack, and I'm a research scientist. The first instrument we chose was MODIS, a passive instrument designed to capture images of the Earth's surface. By pinpointing the location of storms on the Earth's surface, MODIS enables us to determine the geographic coordinates of various regions. For MODIS, we are utilizing channels 1 and 2 to collect cloud boundary data, and this will provide measurements of both the storm locations and frequency. These will be collected in order to find their relationship with convective patterns. The second instrument that we chose is ATMS, which is a passive microwave radiometer that we are using for two different measurements. The first being atmospheric temperature, which we are using to determine the overall global temperature change over the duration of our mission, and the second being wind speed and direction, which we are doing indirectly by measuring the atmospheric pressures, where higher pressures correlates to stronger winds. And the wind speed data is necessary in order to draw conclusions about the correlation between storm movement and convection patterns.
My name is Hari Balaji. I am a budget analyst. One of the agencies we'll be partnering with is the National Oceanic and Atmospheric Administration, also known as NOAA. We'll be utilizing their ground stations from all over the United States to ground truth air pressure data incoming from the ATMS instrument. Part of NOAA's mission as an agency is to better understand the natural world, climate, and weather. Our next partner agency is the United States Geological Survey, also known as USGS. Similar to NOAA's goal as an agency, they aim to provide reliable scientific information to better understand and describe the Earth, while also minimizing the effects of natural disasters. From these partnerships, we will get a 30% discount on the costs of the instruments being used. And finally, our last partnership is with Lockheed Martin. And their aim is to advance scientific discovery and deliver innovative solutions. By partnering with this company, we'll get a 10% discount on the space qualification costs associated with MODIS and ATMS. These three organizations are benefited from this partnership because they'll gain information from us regarding, because we'll be able to inform them in advance from weather severity. And NOAA and USGS can inform citizens to take protocols ahead of time, and Lockheed Martin can use the information to more accurately plan flight plans.
My name is Maria Cosma. I'm a budget analyst. For our cost breakdown, our initial baseline cost was $666.8 million, which exceeded our budget of $260 million, with the heavy distribution in our instruments, our launch site, and our launch vehicle. With the joint mission with all the other spheres, and within the inclusion of support from our partnerships, we reduced this cost to $186.4 million. The chart shows the distribution within our joint mission, with reduced costs in our instruments, thermal and power systems, our launch vehicle, and our launch site. The total cost, which includes a public outreach plan and a budget reserve, is $251.4 million. Some of the costs over time include our data, in which we are using a DAAC storage facility, which has a usage fee of $1 million. We are also utilizing data communication bands of the X band and the S band, which have a combined base cost of $11 million. For our public outreach plan, we are dividing $10 million to promote our mission. 20% of our budget has gone to scientists and mission operators who will be helping throughout the mission. And as a budget reserve to plan for any unaccounted costs, we have reserved 5% of our budget. To determine the savings that we gained by joining with the other spheres, we subtracted the shared costs from our initial costs, which has led to us saving $480.4 million.
My name is Sean Martin. I am a launch and orbit analyst. For our launch site, we have chosen Wallops Flight Facility. We have chosen this because of its proximity to the water, which will ensure the safety of individuals as it launches over the coast, and also as its location near the equator will receive an assist from Earth's rotation and assist it into launching into orbit. For a launch vehicle, we are using the Antares rocket. This rocket is known for its reliability for NASA's resupply missions to the ISS and will be able to have a payload of 6,125 kilograms. For our orbit, we will be using a sun-synchronous orbit with an 80-degree inclination at an altitude of 622 kilometers. This will ensure that we cover about most of the Earth, ensuring that we get as much data as possible. For our satellite bus, we are going to go with a GeoStar 3 bus. It has a lifetime of around 15 years and was chosen because it could fit both our teams and every other team's instrument needs. Meanwhile, as a mission lifetime, we are planning on a September 2032 launch with a 7-month instrumentation calibration period. So then at that time, we will proceed our 6-year mission. Our mission is 6 years long due to the limitations of our MODIS instrument, but we have evidence from NASA's Aqua mission that MODIS can go longer, and thus we will use that data to proceed if we will continue the mission or deorbit and decommission the satellite.
My name is Sam Myers, and I am the Contamination and Risk Analyst. The GeoStar 3 satellite bus was equipped with 4 different instruments, 2 of which are highlighted for our mission. These instruments will be protected from contamination and other risks through the use of multi-layer insulation as well as contamination monitoring packages, or CMPs. Contamination is a risk that all specialized instruments face. Instruments are susceptible to contamination risks such as smeared optics, dirty solder joints, or unclean bearings. Thus, instruments must reach a certain cleanliness level in order to ensure mission success. Particle contamination levels must reach level 750 and molecular at levels F. For our contamination budget, taking into consideration all of the payload as well as the instruments that we are using for our mission, our particulate contamination level was 797 and our molecular was at level G. Unfortunately, this does not reach the levels required for the system end of life. However, we plan to counteract this with assistance from our stakeholders and partners. Mitigations in place for contamination control begin with the assembly of all parts within an ISO cleanroom level 5. Personnel in the cleanroom will be using anti-static, non-particle generating white fabric clothes that must be changed daily. Once the components are individually they meet cleanliness requirements, they will be assembled within the cleanroom and then transported in a mobile cleanroom to Wallops Flight Facility. When loaded and launched, nitrogen flooding and vacuums will be used to maintain cleanroom quality. While in orbit, 3 CMPs will be used to minimize contamination impacts through program telemetry.
My name is Isabel Evans, and I am a contamination and risk analyst. One of our high risks was the impacts that atomic oxygen has on erosion of the satellite surface and degradation of our instrument. Our mitigation for this risk was the use of a silicon dioxide glass coating as a protective layer. Another risk that we had is outgassing and contamination. This could potentially expose our satellite surfaces to the extreme temperatures and radiation of outer space. Our mitigation for this risk is to ensure that our cleanroom procedures are very high quality, as well as performing double bake out to eliminate as many outgassing particles as we can before launching. Another risk that we have is space debris. Because of our orbit's height, the space debris that we're dealing with is smaller. To mitigate this risk, we will be using a space debris sensor to predict any potential collisions and chemical propulsion to maneuver our vehicle in the case that we are going to collide. We will also be using a multi-layer insulation to help with thermal control, but that will also act as another layer of protection against these smaller debris. A specific risk for our MODIS instrument is stray light. This can interfere with the accuracy of our data collected, and our mitigation for this is to use a spectral stray light correction matrix.
Hello, my name is Philip Callahan, and I am the calibration and validation scientist. MODIS will use 3 primary calibration techniques: a black body, which will be set to a temperature of 285 degrees Kelvin in order to calibrate our thermal channels, a solar diffuser, which will be used to calibrate our reflective channels, and a solar diffuser stability monitor, which is used to ensure that the solar diffuser's properties don't change over the course of the mission. In the event that they do change, we can correct for those. ATMS also uses 3 calibration methods: a thermal vacuum, which is done prior to flight in a laboratory, as well as in-flight hot calibration and in-flight cold calibration. As far as ground truthing goes, we'll be using NOAA's automated surface observing systems in order to ensure that our calibration of our instruments is correct and we're getting valid data. The data that we'll be comparing to is the ambient temperature, the wind speed, wind direction, wind characterization, as well as surface pressure sensed by the automated surface observing systems.
Hello, my name is Noelle Searing, and I'm the applied scientist. This mission will improve understanding correlation between weather intensification and convection currents. This will also include changing locations' susceptibility. Human safety is one of the main concerns as flooding and wind speeds intensify. Airborne debris, flooding, and loss of power are some of these effects. Crops and habitats will also be affected through flooding, uprooting, and defoliation. During Hurricane Katrina, 5 million acres of habitats were destructed, and this number will increase as intensification occurs. Precautions will also need to be adjusted, such as stocking up on food, water, and safety instruments, as well as improving infrastructure. One example of this is Norfolk, Virginia, which lifts houses on stilts that are largely affected by flooding. There are also large global and local economic effects. This will be encouraging businesses to have backup protocols, and through the Stafford Act, government spending will change as they can allocate certain funds for these intensifying weather events. Globally, the supply chain and travel will change as the risk of routes is calculated and new protocols are developed.
My name is Lana Assad. I am the Mission Outreach Analyst. And on the board, you can see that we have our mission patch. Our name is arrow, so it's in the center. We are studying convection currents, hence why there's arrows, the red and blue. And we have a satellite in our mission patch in order to represent that this mission is satellite-based. And all of our partners are on the bottom of the patch. For our education outreach, we will be focusing on elementary, middle school, high school, and college level. So elementary and middle school will both have coloring activities, and any mission information given to schools will be integrated into their lesson plans, specifically for climate change, weather, and cloud units. We will have Arrow's mission individuals come over and have presentations at the schools, and additionally we'll have a Wallops flight facility have a tour there. For high school and college level, we will have scholarships and internships. The difficulty will increase depending on the classes or levels. So for our general public outreach, we will have community events in which individuals can go out to public parks or really anywhere within their community and stroll around with tour guides that are volunteers that are informed on our mission and will inform the visitors about what our mission is doing, any updates to it, and its importance, and how you can see this in your daily lives. There will be flyers, pamphlets, and maps handed out there, and this outreach does not require internet to be broadcasted because community heads can inform their community that there is an event occurring. But of course, we do have social media platforms. We have Facebook, Twitter, and YouTube in order to reach out to a broader audience, and that's for ours.
Thank you, Atmosphere. We now open the floor for questions.
Dr. Evan Biedler, College of the Albemarle. I have a question. Looking at historical data, did you find any particular latitude and longitude coordinates that would be points of focus based on your anticipated studies?
Our mission will try to analyze the entire globe. We are not focusing on any longitude or latitude in particular, but trying to get a big picture of everything that's going on.
Hi, Jess Savage, Hypersonics intern. So you mentioned your partner company was Lockheed Martin, but explained that the only benefit they would be getting from partnering with you guys was helping with flight plans. So I was just wondering if you guys took into consideration if they had any delivery objectives that they probably would have wanted for this mission.
I'm not certain on the exact advantages that they would get from this partnership, but I know for certain that by partnering with us, one significant advantage would be the more accurate and more scheduled flight plans.
Bill Moore, Hampton University. Unlike the other missions so far, your data will be most useful in real time. But I didn't hear anything about any kind of system set up to make sure that the data came down, got validated, got quality controlled, and got out to the people who needed it as rapidly as possible. Did you include any real-time data interfaces?
On board our satellites, we do have both S and X-band communication system along with the DAAC ground-based system, and so with that we would be able to easily send the data down and distribute it from there.
Thank you.
Yeah, hi. Another great presentation. Joe Hanley, Program Manager. Your launch site, I think you mentioned Wallops. What is your backup launch site in case something happens, and what would that do to your schedule and budget if you had to switch last minute?
in case we had to swap launch sites, we would probably go for Cape Canaveral. While it may be a bit more of an expensive option, that would go from the reserve budget, but it would still give the same benefits of flying, of launching over the coast for safety, but also being close to the equator, so it's easier to launch from.
What about Vandenberg? Due to your inclination, did you consider that?
No, we have not considered Vandenberg at this time.
Okay, thanks.
Question online from Tara Wise. For mission outreach, if the public were intrigued through your outreach initiatives and wanted to support your mission, what could a layperson do to help?
Sorry, can you repeat what type of person? Okay. So they can help us out through multiple ways, but I think the main one would be volunteering at our events. Because we're trying to do it globally, it's not just centered on one specific region. We really do need as many volunteers as possible. So if anyone was really interested in our mission and was researching it and understood it well enough and wanted to actually help and get involved with this, they could go volunteer at their communities and actually partake in these community events.
Bill Moore again. Atmospheric dynamics are driven by temperature differences, but also very strongly by humidity. But I didn't see any measurements in your chart for humidity. Is there something that's going to supply that information for you?
Our ATMS, if I am not mistaken, it can also figure out the humidity in the air.
Kari Espada, Program Coordinator. With this mission, how would weather notifications change to protect the general public?
The main impact to weather modifications is mostly just finding out which locations are changing susceptibility, so which locations are going to experience these severe storms more frequently. So this will help cities and affected areas understand what precautions they need to take and modifications to all aspects of their community and family life.
Thank you.
Mary Hing, master teacher. I have a question for budget. Pretty much the same question I had before. If you had an unlimited budget, what would be on your wish list?
So if we had an unlimited budget, mainly what we would try to focus on is redundancy for mainly contamination and for risk. We would try to maximize contamination or cleanliness, for our instruments and for other instruments, as well as have additional power systems in case of risks such as debris that we cannot avoid, or other contamination and risks that might damage power systems, especially solar panels, especially. Anything else really could go towards public outreach or even a budget reserve in case, because we have a 6-year mission duration, if we want to extend that due to, as said earlier, the current MODIS instrument has been going on for 20 years. If we wanted to extend that duration, if we had unlimited cost, we could put that money towards extending the mission and getting the necessary materials to extend it, basically.
Thank you, Atmosphere. That concludes all of our questions. Our next team is lithosphere.
Hello, my name is Peter Scott, and our mission, LAVA, stands for Low Altitude Volcanic Analysis. So we are trying to study two key factors that will help us forecast volcanic eruptions, which are surface temperature change and surface deformation as magma rises to the surface. We are focusing on the first strategic goal from NASA, which is discovery, which focuses on scientific discovery. And as our goals from the National Geologic, or as our goals from the Decadal Survey, are S1A, which focuses on accuracy of surface deformation data, and S2B, which focuses on volcanic forecasting and temperature change.
My name is Joshua McLeod. I'm the Deputy Project Scientist. As stated, the mission proposed, the Low Altitude Volcanic Analysis Mission, or LAVA, will study surface deformation and surface temperature changes in volcanically active regions. This will help us determine how volcanism impacts the lithosphere, and it'll also allow us to create forecasts for volcanic eruptions. Now, the data derived from LAVA will provide a viable means to study volcanoes globally, providing useful information to volcanologists, emergency response agencies, and can aid in providing data to pass bills in the legislature. Now, all of these elements help contribute to our mission statement. LAVA will monitor volcanic activity around the world, focusing on surface changes and alterations in surface temperature in volcanically active regions.
My name is Angelina Stevens, and I am a research scientist. Our mission goal is to study the physical phenomena that occur prior to and immediately following a volcanic eruption. We have two science goals. The first science goal is to measure the ground deformation and surface temperature around volcanically active regions. This will allow for future forecasting to possibly be made in order to prevent problems with economically and for the residents who live in the regions. In order to do this, we need to measure the surface topography and temperature, which will be done using a synthetic aperture radar, or SAR, and a moderate resolution imaging spectroradiometer, or MODIS. The second goal is to collect new and continuously updated and more accurate updated data on the ground topography to allow for more updated and accurate models to be made of the volcanic regions around the world. This will be done only using SAR, and both instruments, SAR and MODIS, will be continuously checked with ground truthing in order to make sure that the instruments are accurate.
My name is Hudson James. I'm a research scientist. The image to the left shows synthetic aperture radar, or SAR, aboard the CSAT. SAR is an active instrument that operates on L-band wavelength and utilizes phased array antenna in order to measure surface displacement caused by ground swelling as magma rises to the surface. Ground swelling typically only elevates land by a few centimeters. However, SAR is capable of measuring within millimeters. The rightmost image shows a passive MODIS instrument attached to the Aqua satellite. For our purposes, MODIS is used to measure surface temperature, again, as magma rises to the surface and warms up the soil.
My name is Rashad Prabhu, and I'm the budget analyst for our group. For our mission, we've partnered with the United States Geological Survey, or USGS, and the National Oceanic and Atmospheric Association, or NOAA. We have partnered with these organizations to reduce our instrumentation costs, as well as validate our ground subsidence data and calibrate our instruments accordingly. We will also provide our global data that we collect to these organizations to add it to their database. We've also partnered with Northrop Grumman to reduce our cleanliness costs and also give them feedback on their calibration for the instruments so they can provide better technology and gain positive publicity. In the next slide, we will discuss our budget distribution without sharing. So our instrumentation is our primary driver for our budget analysis, and because they determine the power, temperature, and space qualification costs, as well as cleanliness. As you can see in the pie chart, a majority of our budget is for the space qualification and also for power and temperature to ensure that our instrumentation remains operational for the duration of our mission. We've also allocated $50 million for administrative costs, $7.5 million for data storage and communication, and $10 million for public outreach. Together, our cost is $950 million after saving $157 million by partnering with these organizations. Our net budget is then negative $700 million. After combining our budgets across the spheres, we were able to split launch costs, power costs, and temperature costs, and as well as share MODIS and its space qualification and cleaning costs. We've saved over half of our initial proposed costs, as well, and combined with our costs that we saved through the organizations that we partnered with, we've saved a total of $730 million, and across all the spheres ended with a $78 million budget surplus.
My name is Ryan Lawrence. I am the launch orbit analyst, and we decided our launch site would be Wallops Flight Center in Virginia, which is nearby mission partners reducing transportation costs. Our rocket is the Antares one, which has plenty of payload capacity for our satellite, and it will launch the satellite into a sun-synchronous orbit in September of 2032. Our mission goal is to for a length of 10 years, and with a eventual possible decommission in 2042.
My name is Gabriel Ignacio, and I'm the Contamination and Risk Analyst. As you can see with our layout, it is intended to meet the needs of all of the instruments while keeping them clean from outside contamination. If you look at the top right, you'll notice that the MODIS instrument is not near any other radiators or coolers or heaters due to the fact that it does not need any external thermal systems, which is contrary to our active instrument, which is SARS, which does need a heater and is placed next to the batteries, as the batteries also need heating. The CPU and onboard data storage have been put in the right middle, away from all the other instruments, because the CPU is of less clean quality than the remainder. We have multiple contamination measuring packages across the bus in order to monitor the contamination levels throughout the mission. In order to ensure accurate data throughout the mission, we have to make sure that the instruments remain clean at all times. And so all instruments and all parts that are in contact with the instruments were cleaned with precision quality. Those not in direct contact with the instruments were cleaned with visually clean quality, and the CPU was the only part that was cleaned with general quality. We had to calculate our end-of-life budget for contamination, and our particulate contamination was 816, while our molecular contamination was level H. There are multiple risks associated with the mission, and some of those are up here, although we could not include all of them. I would like to draw attention to number 6, which is if we are unable to downlink all of the information, we are going to have extra onboard data storage to ensure that the data is preserved and we are not going to be losing any data if we can't make that connection. And if you look at number 7, if an instrument in some catastrophic event is lost, we will be supplementing the lost data with ground data and other satellite data, even though it may be of lesser quality.
My name is Thomas Edenfield. I am the calibration and validation scientist. If you look at the slideshow presentation at the top, you will see the USGS Eastern Geographic Center. We will be using this as a ground station and performing missions 6 times per year to ensure surface temperature capacities are accurate. The DAAC center that we will be using is the John Wesley Powell Center for Earth System Analysis and Synthesis. This will be used to archive, distribute, and calibrate data. Calibrations will be performed at dusk and dawn due to the sun synchronous orbit we will be utilizing. This is because the satellite will be going over these stations at around that time. Next slide. This is a calibration schedule. For pre-launch test, the satellite instruments will be tested before actually being put into space during cleaning and decontamination procedures. After the launch in September of 2032, MODIS will collect data for 51 days, and then afterward will collect data. SAR will do the same for 90 days. MODIS will use its self-calibration, onboard self-calibration in order to calibrate itself, and will be supplemented with ground truthing through ground station missions about 6 times per year. The SAR instrument will be using mainly topographical data from ongoing Virginia elevation measurements performed by USGS.
My name is Nina Argel, and I'm the applied scientist. Lava is important to conduct because it would put response plans into action quicker. There'd be quicker evacuation, more safety ensured, and communities would endure the least amount of economic loss possible. And lava has many economic benefits and on both a local and global scale. There'd be money saved in infrastructure building, there'd be less casualties, less injuries, and there'd also be less foreign aid distributed because of our research and how it forecasts and warns people in those regions. On the next slide, we emphasize how lava saves lives, causes less to become displaced and less devastated, and also air transportation is affected by volcanic eruptions. An example being Eyjafjallajökull, which is an Icelandic volcano that erupted in April of 2010. It sent a large ash cloud across the continent of Europe and caused 48% of flights to be canceled, leaving 10 million displaced. And we would use our data and apply it to situations like these so that these consequences are not as devastating.
My name is Kaylee Beck, and I am the Mission Outreach Analyst, and as shown, our logo is designed as a triangle, and it symbolizes a caution sign, and it reflects our commitment to raising awareness and promoting safety on volcanic activity. Our logo includes various colors, and the red, orange, yellow colors represent the energy and heat of lava and volcanic activities, and the brown color reflects the structure and lithosphere of the volcanoes, and the gray reflects the ash from volcanoes. The blue and green shows the mission's focus on Earth science and volcanoes on Earth. The black shows the outer space that our satellite will be launched into. And the white color reflects the orbit following satellite and path around the Earth. Our partnership logos are at the bottom to demonstrate our mission's collective efforts. We have an educational outreach plan where we will keep public interest over the duration of the mission by participating in participating in yearly science exhibitions, opening workshops and public lectures every 6 months in public institutions such as schools, community centers, libraries, and museums. And we will also have yearly scholarship opportunities to students where they could have a writing and art competition. Furthermore, we will publish press releases and fact sheets, and our outreach plan also includes a K-12 lesson plan where we will have some activities such as virtual field trips, internships, summer programs, and volunteering opportunities, as well as science experiments. We will inform teachers by directly interacting with them, visiting teachers during planning periods, and reaching out to college and career specialists in school, and attending teacher conferences. Finally, to engage with the public, we will also be utilizing merchandising and social media. And thank you for listening.
Open the floor to questions.
This question is for contamination and risk. Could you explain why it is important to have instruments that are precision clean?
If we do not clean the instruments, then the measurements taken by them will be inaccurate, and that would be poor for our data and our mission goal.
Jordan Edwards, master teacher. How more accurate do you think your satellites will be in predicting volcanic eruptions than the seismology and ground sensors that we already have in place?
I believe that the main advantage that satellites have over ground sensors is just the unpredictability of ground swelling and how much it actually affects the land. As I stated before, most ground swelling is within centimeters, maybe even millimeters. In extreme cases, it can be meters and kilometers, but it's not likely. And this area takes place over square kilometers, and it's just not easily detected by ground sensors, and if it was, it wouldn't be extremely accurate compared to satellites.
To add to that, we are also measuring the topography and surface temperatures both before and immediately after the eruption. So any instrumentation that might be at like the mouth of the volcano will not be able to take any data on ground deformation or temperature because it would just be annihilated by the pyroclastic flows.
You said during your Megan Clark, master teacher. You said during your timeline that there was a possible decommission. Is it possible that you would extend your mission?
If the instrumentation is still operational at the 10-year mark, we will consider extending the mission based on funding.
Hi, Jess Savage, intern. I was just wondering if you guys had a mitigation plan for your communication systems between Earth and the satellite. What would happen if that powered down?
We have two communication systems, an S-band communication system and an X-band communication system. If both were to fail, we would lose contact, but we believe that having two is sufficient to reduce the risk.
Mary Hing, master teacher. My question is for budget. Unfortunately, you're not getting an unlimited budget for this question. I noticed on the initial budget plan for the 5 spheres that your budget is almost half of the entire budget. Is there something that you could have cut in order to allow the other missions to have more money for their studies?
So like our research scientists were mentioning before, our SAR instrument is incredibly accurate for measuring surface topography changes. and this requires a lot of power and mass for our satellite and bus, and that is what's causing a lot of the costs, as well as the space qualification years and the cleanliness that needs to be taken into account for these instruments. So that is why our lithosphere is taking up almost 50% of the total budget costs.
Okay, I have a follow-up question. If you were given an unlimited budget, what would you give to the other spheres missions?
So I think a lot of our shared instruments, power systems, propulsion, a lot of that could be, as other groups were saying before, cleaner and could have higher space qualification years to ensure its proper execution and functionality. So since we're sharing that, all the other groups get to benefit from that extra money that we will have in our budget.
Thank you.
Dr. Evan Fiedler, College of the Albemarle. In looking at the data that you anticipate to collect, do you see any positive relationship in harnessing the use of this geothermal energy? Did you discover any?
We did not look into studying geothermal energy. This is mostly for tracking surface temperature change as a result of rising magma.
Speaking of unlimited budgets, so similar to this last question, do you see any opportunity to establish potential predictors of air quality impacts and other direct impacts from volcanoes?
Starting off, our team was very ambitious with its goals. We wanted to implement a hyperspectrometer on our satellite called Nachos. Funny name, but it would detect sulfur dioxide, nitrogen dioxide, and carbon dioxide that all radiate from volcanoes that are predicted to erupt. And just measuring that alone, those are our harmful chemicals and would help in that.
I would like to add on to that. So currently the instrument that we have on board, the MODIS, it also has capacities for tracking aerosol, which won't be as accurate as what we previously wanted to look at. However, it provide us some insight into tracking aerosols and before and after volcanic eruptions.
Hi, I had another question. So I was just wondering, how would you engage the public that doesn't live near volcanic areas?
We will engage people who don't live near volcanic areas we have not yet developed a plan for that, but they will considering the impacts that they will have even when they're not living in volcanic areas. I feel like we believe that it is necessary to still engage them into this mission.
Is there a concern that you are tracking the likelihood of volcanic eruptions, that you may actually increase the deaths related to volcanic eruptions from those people that can now plan to travel to witness it happening?
I can't speak for those people, but I'm not sure. There are a lot of people who travel to see volcanoes, one being in South America, where a lot of people were mourning the loss of their homes and their village, but people went to go take pictures. That's tourism, but I can't speak for those people who go, but this would help more people evacuate and take their belongings, and it would also help the local economies, because a lot of farmers, they lose their crops, but then they can take it with them if they have a warning in advance.
I have a question from Tara Wise. We see that this mission has aligned with Northrop Grumman as a sponsor. What is this mission's expectation for what level of support is anticipated by Northrop Grumman, or what kind of support would be ideal to receive from private industry? In other words, how can a company within the private sector best support this team and its mission?
So like I was saying earlier, they will help us reduce our cleanliness costs, which is a large component of our budget. And so by cutting this cost, we were able to spend more money on this sector and also share our budget with the other groups.
And I believe that was our last question. Thank you.
All right, our last and final team will be Biosphere.
Hello, my name is Shreya Thirajan, and I'm the project scientist for the Biosphere. Our mission is PRIDE, which stands for Phenology Rates Influencing Distribution Events. PRIDE aligns with NASA's Strategic Objective 1.1, which aims to understand Earth's systems and its climate. It also aligns with Objective 1.3, which aims to ensure that NASA's science data is accessible to all and provides practical benefits to society. Additionally, this mission accomplished the goal of E1A described in the Decadal Survey. Specifically, PRIDE is able to fulfill the task of quantifying the distribution of the functional traits, functional types, and the composition of terrestrial and shallow aquatic vegetation and marine biomass, both spatially and over time. Overall, our mission goal is to study an aspect of climate change. Specifically, we're looking at the increasing surface temperature and its relation to the bee distribution trends across North America. For a bit of background, if you look on the graph to the left, on the right, you can see that the average surface temperature has increased dramatically over the past century.
Hi, my name is Amar Guello. I'm the Deputy Project Scientist for the Biosphere. And our mission goal is to determine the relationship between rising surface temperature and photosynthetic activity to determine phenology rates. This would then be compared to bee population numbers to determine the effects of changing climate. This will impact society, the economy, as well as the agricultural sector. Our mission will be measuring temperature, measured in Celsius, plant fluorescence, an indicator of photosynthetic activity, as well as bee population numbers, which will all be measured and compared over time. Our partnerships will be with the CSA, the USGS, as well as the NOAA.
Hello, my name is Isabella White, and I'm the research scientist for the Biosphere. So let's talk about phenology. These timelines represent calendar years, and these boxes represent the time frames in which bees and plants rise in the spring and are ready for pollination. So as you can see in the top graph, under normal temperatures, these pollination windows align and plants are able to be fertilized. However, in the bottom graph, when extreme temperatures occur, we see a drastic misalignment of these pollination windows, and plants rise very early in the spring and die before they're able to be pollinated. So when these plants die, they're not able to reproduce. Our objective is to assess the relationship between temperature and plant phenology in order to better predict the consequences of global climate change on bee distribution in the United States. In order to understand this relationship, we'll be comparing the misalignments of those pollination windows with the distribution of bees. We'll also be assessing fluorescence
in order to study photosynthetic activity and thus phenology levels. We'll be using MODIS to measure temperature and fluorescent levels, and we'll be using data from our partnership with USGS on the national distribution of bees in order to draw conclusions. Later in our mission, after our satellite has been collecting data for a few years, we'll use historical and current data on temperature and phenology to deduce trends in the data. With those trends, we will build an observable relationship between temperature and bee distribution.
Hello, my name is Rachel Karras, and I'm the research scientist for the biosphere. Our mission instrument will be the Moderate Resolution Imaging Spectroradiometer, or MODIS, and it is capable of taking all the measurements that we need, including surface temperature and fluorescence. Surface temperature is by far the simplest of our factors to measure, but it shouldn't be underestimated as important in the context of the other data that we'll be taking. We'll also be measuring fluorescence as a way to track phenology trends. The satellite will include a direct broadcast signal antenna in order to relay regional information, and we'll also be making use of a DAAC in order to store and process information. These in combination will create an efficient and secure way to collect our data.
Hello, my name is Ali Zhang. I'm the budget analyst for the Biosphere team. For our partnerships, we have decided to partner with USGS and CSA because they will be able to provide on-ground data for the bees we will be studying, and CSA will be able to give us a 15% discount off of power and thermal systems. In addition, we have chose Lockheed Martin to partner with also because they give us a 10% discount off of qualification costs. With these partnerships, we were able to save a total of $21 million. For our proposed costs, before we added our partnerships and negotiated with the other teams, we had a total of $755.5 million, which was $404.9 million over the budget. But after inputting our partnerships and negotiating with the other teams, we now have a baseline cost of $183.3 million, which is $73.7 million under the budget. On the top chart, we have a breakdown of our baseline costs, and the bottom chart is the breakdown of our proposed cost. As you can see, the qualification cost uses most of our budget, whereas electronics, which includes onboard data and CPUs, uses the least amount of our budget.
Hello, my name is Yelgun Badardine, and I am the Orbit and Launch Analyst. So for our launch site, we decided to use the Wallops facility due to its affordability. For our bus, we decided to use the GeoStar 3 due to its 15+ year lifespan, its 1,000 kilogram max payload, and its 8,000 watt power capacity. We also decided to use the Sun synchronous orbit due to our MODIS instrument and for better coverage. So we would like to launch our satellite in September of 2032 with a 7-month acclimation period, which means we will be able to start collecting data in April of 2033 when photosynthetic levels begin rising. After 6 years of collecting data, we would like to do a MODIS update check on the instrument to see if we will be able to continue using the instrument, and if so, we will deorbit the instrument in 2042 into the Pacific Ocean. And then in the next slide, it shows the diagram for the GeoStar, or our payload, and in the upper right corner is our MODIS instrument, and you can also see the devices for the other spheres.
Hello, my name is Jaden Koh, and I'm the Contamination and Risk Analyst for the Biosphere. Up here is a list of our parts that need to be cleaned, and we chose the cleanliness grades based on their function and collaboration with other teams. Our clean room level that we chose is ISO 5, and our final particulate cleanliness level is just under 800, and our final molecular cleanliness level is level J. While these levels are not ideal, the layout of the bus, as shown on the slide before, will help mitigate the risk of our more sensitive parts being contaminated. And on the next slide, there's a list of our risks as well as the pre and post mitigation risk matrices. Many of our risks will be shared with the other teams due to us sharing one satellite, and thankfully this means that we can mitigate these risks collaboratively. However, we do have two risks that are specific to our team, one of which is what if our sponsoring organizations decide to drop funding for our mission? To mitigate this risk, we will properly inform these sponsoring organizations of the benefits they will receive from our data for their future research projects. The second risk is what if we don't receive the bead distribution charts in time? The mitigation for this will be to contact other environmental agencies for similar data.
My name is Ben Benares. I'm the calibration validation scientist. So specifically for the MODIS instrument, which we will be using, we'll need a 51-day acclimation period, after which we can start collecting data. And for ground truthing, we'll be using stations in the USGS ground station network, mainly because it's very cheap, it's affordable, and the data that they provide is very, very accurate and consistent, which is exactly what we need for a 6-year mission period. MODIS has 3 separate onboard calibration assemblies, one of which you can see behind me, the spectroradiometric calibration assembly, which allows for calibration at several different wavelengths of light. And when we combine ground truthing with these 3 different calibration assemblies and different calibration methods, and do it on a specific calibration schedule over the entire mission period, we can ensure that all data is valid and accurate for as long as we'll need it, or as long as the MODIS instrument will allow for it.
Hello, my name is Emma Forrest, and I'm one of the applied scientists. The data we will be collecting in this mission is very important and can be applied to a multitude of areas. What we'll be doing with this data is finding the correspondence between bee distribution, plant phenology, and surface temperature. Looking at this information, we can use it to indicate the effect of climate change on a variety of ecosystems. If you look on the next slide, you can see a chart that shows some of the economic impacts of bee distribution and that bees have on agriculture. So on the left-hand side, you can see a list of agricultural products that are impacted by honeybee pollination. Any of the products that have a dark green line need the bees in order to produce their flowers or vegetables or whatever they're going to grow, and the ones with the light green lines represent any plants that need honeybee pollination to produce seeds and continue reproducing.
My name is Isaiah Green. I'm also an applied scientist. As my fellow applied scientist says, bees do have a major impact on the economy. And while researching, many sources believe that without bees, there would be a $15 billion downturn in the U.S. economy due to the loss in agricultural production that bees have. These economic impact does also extend to the textile industry, since bees are significant pollinators of cotton. A decrease in the pollination of cotton leads to a reduction in the availability of this material, which would just make the clothes that you are buying more expensive. Our mission also has some societal impacts. One of the first things we found for the societal impacts was that our mission will increase the public awareness of the globe, because our mission is looking at how the world is changing by plant phenology and bee data. The second thing we found was that our mission will also help educate people, and this is very important since climate change does have broader implications, and this is another reason this is important is because one of NASA's main mission as a global agency is to educate people all around the world. Another thing we thought that was important that our mission will be able to do is inform policymakers and environmental agencies on how to create effective strategies to migrate climate change. One example of this that we have is the EPA. On this year, May 11th, they proposed a new carbon pollution standard that they want to get accepted in accordance with the Clean Air Act. Our findings that Pride will find will be able to help these policymakers get this law passed to get new carbon pollution standards.
Hello, my name is Bidushi Besnet, and I'm the Mission Outreach Analyst. And as for the name of our mission, PRIDE, it is an acronym that stands for Phenology, Rates, Influencing Distribution Event. We chose this name because our team focuses on collecting data and finding a correlation between phenology rates and V distribution in the United States. And as for the mission logo patch, we went with a traditional circular patch where each element of the patch represents something that we are doing with the mission. For example, the map is showcasing the geographical, is to signify geographical focus, which is the United States. And as for the satellite, the satellite is the mode we will be using to collect data on the phenological rates. And we have our partner logos right beneath the flowers and the United States map. And as for education and public outreach, for elementary school and middle schoolers, we'll be providing plan kits for schools across the U.S., and we'll be partnering with local museums and libraries and conducting public events that will be open for students and general public alike. As for high schoolers and academia, we'll be having scholarships for scholarship open for undergrad students, along with grants that will be open for scholars who want to research more about bees and anything that aligns with our mission goals. And we also have summer internship programs open for high school rising seniors and undergrad students, and they can work with us and help us in our mission and maybe perhaps join our team in the future. And for general public, we have the fact sheet that they can refer to if they want any further information. And they also have access to plan kits that they can use in their backyards. And we also have our social media platforms that they can access and get updates on our missions.
Hi, I'm Emily Warren. I am the Mission Outreach Analyst, and the first thing I'll be focusing on is the fact sheet. The fact sheet will provide the general public with more information about our mission, both the history and science goals, all in simple to understand terms for the general public to have a better understanding and fully be able to invest in our mission. The next part will be a press release. We will do multiple press releases, some before the launch even occurs, some during the whole duration of the mission. These press releases will have time, dates, locations, anything else the public may need to know about our events. The next thing we'll be doing is a mission website. The mission website will really tie this all back together. It'll include our mission goals, statements, scientific goals, any interactive maps that will help the general public see exactly what's going on in their location. And it will have information about the mission launch week, which we will be teaming up with the other 4 teams on our satellite to do. Now with our social medias, the first one we'll be looking at is Twitter, which has a very unique user platform, as it is very interactive compared to other social medias and actually allows us to have a conversation with the general public, meaning that we can further engage them in our mission. Next, what we'll be looking at is Instagram. Instagram has about 2.3 billion users, 70% of which are under 35 years of age, which really means we'll be able to capture that younger demographic. And lastly, we'll be looking at a YouTube channel, which we will be putting mission launch updates along with live streams and videos of why our mission is important. Thank you.
Good afternoon, Biosphere. My name is Marta Sintra. I'm from Master Teacher for Cryosphere. I do have a question. I know you concentrated on how climate change can affect the patterns of distribution of the bees, but are you considering other factors, like, for example, the colony collapse disorder or the killer bees? They're moving very fast here in the United States from the south to the north. How those factors can affect your data collection?
So this would actually, for the bee distribution trends, we're actually, since we're partnering up with the USGS and NOAA to get our bee distribution data, we are gonna sort out for the different populations of bees we'd look at. Currently, we do not have that data yet, but we would factor into that when we are into our data analyzation process.
Bill Moore, Hampton University. This actually leads right into my question, which is, I think you've identified an important data gap, which is that nobody's responsible for keeping track of the bees. So would a recommendation from this mission group be that there should be some federal agency somewhere put in charge of keeping an eye on the bees, among other pollinators, I presume? This is kind of maybe more for the outreach folks.
I do think that would be very important in the future to have a federal agency focusing on that, along with keeping track of other animals and wildlife that are very vital to our ecosystems. And setting up in the future would be something that we would maybe talk to legislators about. Thank you.
Jordan Edwards, master teacher. So we've seen a lot of presentations on this particular satellite. All of your colleagues on other teams, they plan to collect data through April 2043. However, you are planning to decommission their satellite in September 2042. Have you discussed this with them?
I think that was a miscommunication error on my part, because I believe that we were doing 10-year mission duration starting in 2032 during our launch. I hadn't realized that it was when our data collection would start in 2033. So that was my error.
Master teacher, and my question is, can you use this data to also explain trends within other pollinator communities like butterflies?
Right now, we're only focusing on bee studies. We haven't looked into other pollinators, but if there was a branching out of more bee pollination studies, we could also create other pollinators such as butterflies, bats, birds, all of that.
Yeah, hi, Joe Hanley, Program Manager. Again, great job. I really enjoyed thought it was great that you have a strategy to engage with policymakers. And associated with that, if you are successful and you have an extended mission life and the funding to do it, is there new science objectives you would propose to sell the Congress on getting that budget beyond just the pollination?
So as we just said, that we would like to extend our mission into looking at other pollinators, as well as the previous guy talked about how we want to look at a federal agency, making sure we are tracking bee data. That would be something we extend to with policymakers and making sure that's a law that makes sure we're studying.
Okay, thanks.
Perhaps this is Ivanka Todd with NASA, and maybe building on that question, a key driver of bee activity obviously would be human activity such as land use changes. And I was curious whether that's something you have considered as part of the mission, and also whether you considered what we heard from some of the other groups, such as convection currents or weather patterns that are also climate change driven and could be basically sort of improve somewhat the results in terms of the effects of climate change on the bee activity.
That's a really fascinating question, and we have not considered a lot of those layers, but they would be interesting. And again, building off the last two, if we had extended time and funding, that would definitely be something to invest our time and study into.
Karia Spada, Program Coordinator. You displayed that almonds have a $2.8 billion economic impact. In California, almond farms are the source of water distribution and neglect for the public. How would you defend this for a California policymaker?
Can you repeat that statement one more time for me, please?
Hello? You stated that almonds have a $2.8 billion economic impact, and with the pollinators, for your bee pollinations, right? California's almond farms are depleting the water source for the citizens. How would you defend this for a California policymaker?
In reality, I'm not actually sure how I would defend that, but yeah.
I had not realized that statistic, and I can look into that further, but almonds do go further than California would affect the economy nationwide. So it would be able, we'd be able to like get it through with other states, and they might be able to help us persuade California.
Hi, Jess Savage, hypersonic design intern. So going back to outreach, you mentioned that the primary three groups that you'd be focusing towards were, I believe, middle schoolers, high schoolers, and the general public using websites, Instagram, and YouTube. But I was just wondering if you considered that also using TikTok as a platform, mainly because that is also popular within those three demographics.
So yes, we did consider using TikTok. However, as right now is owned by a Chinese government, Chinese organization, we're unsure as a federal agency right now if we would be able to create one, but that would be definitely something that engages the public and interesting to look into in the future.
I would like to add into that, YouTube and other several social media companies have branched out into a short form content creation like TikTok with YouTube Shorts and Instagram Reels. So we can give the general public short form content throughout those platforms instead of just relying on TikTok, which is a Chinese company, and we don't have much information on what they do with their data. So that's why we are going to rely on companies like Instagram and YouTube instead.
Thank you, Biosphere. That concludes our questions. All right, thank you to our mentors and families that joined us for the panel review today. This concludes our mission design panel review.